Welcome guys, today we're going to be learning about how to factor out quadratic equations in a way that you haven't learned before. So basically, if you weren't able to factor or kind of get how to factor quadratic equations, today I'm going to be teaching you two different methods. If you didn't get the X method, it's going to be a little twist on that. Or if you don't get the X method or the one I'm going to show you entirely, there's another method on that, which mathematically you're not going to like really piece things together, but like then I'll show you how to do it in that. So first, let's start with just the regular quadratic equation in standard form, which is what? Ax squared plus bx plus c, right? So first I'm going to be teaching you the X method, but this X method has a little twist, right? So this is the one that you already know, right? Just regular X, but the one I'm going to be showing you today has a line straight through the middle. So I'm going to be going more in depth about what that is in a second. So to represent the values in this X, right, we're going to have, like the regular one, A times C, right? Right. So A, right, times a constant, right? And on the bottom, we're going to have the coefficient, which is Bx, and then B, right? Then here we're going to have P and Q. Now P and Q, what does that represent? P and Q is the answer that you're going to get at the end, so it's just a variable to represent those answers. So like, for example, you're going to have, I'll show you in a bit. So it's going to be like the number that you're going to get right here. So it's going to be whatever number here, whatever number there. And I'm going to come back to this later. But here, we're going to put A and A. And now the equation to represent this, we're going to put it actually in these parentheses, which is like what the actual factored out number is going to be, which is AX, right, plus P, so AX plus P, and AX plus Q. Hopefully you can see that's very small, but X plus P and X plus Q. Now why do we do that? Because right here we have the A, right, and then we have the variable to represent our answer, and then we have the other parentheses answer that we're going to use also to represent. So look, we have AX plus P, so we just put an X here and plus this number, and an X here plus this number. That's the equation to represent this. So let's use it in an actual equation. All right, so we can do a simple one. We can do 2x squared plus 9x plus 10. So 2x squared plus 9x plus 10, just so we can understand for this, for the sake of understanding, right? I'm just going to put the equation standard form of how it should look. So we have A, B, and C, right? Then let's use our X method. We use it right here, right? Put a dash through the middle. So first on the top, we have A times C. So here's A, here's C. 2 times 10 is what? 20, right? Then B on the bottom. So B, which is the coefficient, is going to be 9. Put 9 here. Then we have the two A's, which are going to go here. It's going to be 2, 2, right? Then here is going to be P and Q, which is representing something that can multiply to 20. It's going to multiply to A, right? And add to B. So what multiplies to A and adds to B, if you don't know, right? This one is an easier example, but if you have a harder equation, we can just write out the factor tree here. So multiplies to 10, you can start at 1, 1, 20, 2, 10, 3, no, 4, yes, 4 and 5, and 4 and 5 adds up to 9. So here we're going to put 4 and 5, which is representing PQ, which is going to be our answer. And then, just like we did before, we're going to write 2, right? So this is A. You're going to write AX, which is 2X. So let me write it out for you guys. 2X, right? And this other one is going to be 2X, right? And all you have to do is plug in the P and the Q. So plus 4 plus 5. And then just simplify, basically, or factor out whatever you can. So here, can anything be factored out? No. And here, anything be factored out? Yes. So you can factor out the 2. It's going to be x plus 4, right? X plus 4. And then 2x plus 5, right? So x plus 4 and then 2x plus 5. This is a very easy way you can do it. Obviously, like here, I went in a bit more depth on here and then factor tree and then, explaining this. But this is a very fast method because a lot of the stuff you're going to be doing in your head, so I was just walking you through a little bit of the thought process. But yeah, it's a pretty easy method without having a lot of work, just having just the x on the side, right? So let's try it with another problem. So let's write our tree, little x, So a times c, what is that? 12. And what is here? 13. Then what times 13, right? Now what times 12 is going to add up to 13? Which is 12 and 1. So it was 12, 1, and put a right here, right? Then write that out. 3x plus 12, and then 3x plus 1, right? Factor out 3. Right? And boom, just like that, you have your answer, right? Otherwise, you'd be doing a lot of work, right, for other problems as well. But here we just have our x method, right? And very quick, just put the a, c, b, p, q, right, and then a right there. All right, so that's that method. I'm using the same equation. We're going to use a different method. Now, you're basically doing the same exact thing, but it looks a bit different because if you don't understand the way to do the x, here's another method, and hopefully you understand this one. So, first, you're going to multiply a times c, right, like the last one, right? Write it out, plus 12, right? So a times c. Then, you're going to put regular what it was, 13x, right? Then, we're going to put the a. Since you multiplied it out, don't write the number. Just write x squared. So x squared plus 13x plus 12. Then, you're going to kind of factor out what that is. So this multiplies to 12, adds to 13. So same thing, 12 plus 1. And then your answer's not finished here, but what you're going to do is you're going to divide out, or right here you're going to put like a fraction, divide out your a. So 3. And what is that going to be, right? So you're not going to simplify this fraction, right? Rather, you're just going to move this number to your x. All right, it sounds kind of weird, but it works. 3x plus 12. All right, move this. 3x plus 1. And, oh, missed something. Also, make sure you simplify. So we're going to factor out 3. X plus 4. And 3x plus 1. Right? So, to explain again what we did here, we multiplied a, let me erase this so you guys can see a little better. Multiplied a times c again, right? And we're putting it at the end, right? So we're just moving this right there. We're taking out this, so it's x squared plus 13x plus 12. Then we're putting this in our two little parentheses. Then we're kind of doing the same thing as the x tree, where you basically find something that multiplies to 12, it adds to 13. And so you do that really quick. And then, oh, marker. You do that really quick, and then you put a divided, or in a fraction, on the p and the q, right? And then you just move that number to the x, so 3x plus 12, 3x plus 1. Simplify, factor out the 3, x plus 4, 3x plus 1. So that's what we did there. It's a different method. You know, it looks like a bit more work, but it's kind of simpler if you don't really want to understand like the math portion of it, like from the last example. So it's a bit more simpler if you understand that one. But I'm gonna do another example. So let's do 3x squared plus 10x plus 8. 3x squared plus 10x plus 8. Yep. Okay. So we're gonna do that example again. 3 times 8. Let's write our equation. 3 times 8, 24, right? What multiplies to 24? Adds to 10, 6 and 4. X plus 6 and x plus 4, right? Then what was our a? Put in the bottom. 3x plus 6. Put arrows. 3x plus 6. 3x plus 4. Factor out 3, because here 3 can be factored out. X plus 2. Then this is just stays the same because nothing can be factored out. And that is your final answer. X plus 2, 3x plus 4. So this is another example on how to do it. Yeah, hopefully you guys got that. But this is just kind of a way, so like a cool other way to do this, factoring out the quadratics. Yeah.